Did you know that electricity can be used for space propulsion? That's right. Unlike traditional chemical propulsion systems, electric propulsion uses electricity to generate thrust. So, are the electric propulsion systems better than chemical ones? Electric propulsion systems are much more efficient. They have much higher specific impulse, which means they can generate thrust for a much longer period of time. Specific impulse, indicated as is a measure of a rocket engine's performance. It's defined as the ratio of the thrust produced by the engine to the weight of the propellant used per unit time. It's usually expressed in seconds. A high specific impulse means that an engine can generate a lot of thrust with a relatively small amount of propellant, which makes it more efficient. In the world of space propulsion, specific impulse is a key factor in determining the effectiveness of an engine. It is used to compare the efficiency of different engines and to determine the best choice for a particular mission. The specific impulse of chemical engines is typically in the range of 200 to 450 seconds. Whereas electric engines can have specific impulses that are an order or two of magnitude higher, ranging from 1,000 to 15,000 seconds. The difference between the specific impulse of chemical and electric engines is primarily due to the difference in the way they generate thrust. Chemical engines burn a mixture of fuel and oxidizer to produce high-pressure hot gas, which is expelled through a nozzle to produce thrust. Electric engines, on the other hand, rely on the acceleration of charged particles, either ions or electrons, to produce thrust. This process is much more efficient than the chemical reaction, resulting in a much higher specific impulse. Additionally, electric engines can be operated continuously for long periods of time. While chemical engines typically have a limited burn time due to the limited supply of propellant. There are several types of electric propulsion systems, including electrothermal, ion, and Hall effect thrusters, and electromagnetic systems like the MPD thruster. Let's take a closer look at each of these systems. First, we have electrothermal thrusters. These use heat generated by electrical resistance or by an arc to vaporize a propellant and generate thrust. The specific impulse of these thrusters ranges from 300 seconds to 1000 seconds and the thrust is low, from 0.1 Newton to 6 newtons. Next, we have ion and Hall effect thrusters. These systems use electrical fields to accelerate ions and generate thrust. They are highly efficient and ideal for deep space missions, because the specific impulse can be as high as 15,000 seconds with a thrust of about 5 newtons. Finally, we have electromagnetic systems like the MPD thruster. MPD stands for magnetoplasmodynamic. It works by generating an electrical current in a plasma, which then generates a magnetic field that generates thrust. Typical specific impulses are higher than 5,000 seconds and the thrust can be higher than 25 newtons. If electric propulsion systems are so efficient, then why haven't they replaced chemical propulsion systems? The reason is that electric propulsion provides low thrust compared to chemical propulsion and it is not suitable for primary propulsion. But not all electric engines are the same. Ion thrusters, thanks to their very high specific impulse, can be used for the main propulsion of some long-duration missions. In fact, several missions have already used electric propulsion systems, including Deep Space One, which used an ion thruster to travel to an asteroid and back. As we have seen, MPD thrusters use magnetic fields to generate high-temperature plasma and then accelerate the plasma to generate thrust. MPD thrusters offer high thrust and specific impulse, making them attractive for primary propulsion. However, MPD thrusters require a very powerful energy source, such as a nuclear reactor, to produce the high power levels required to drive the thruster. Currently, there is no practical way to provide the high power levels required by MPD thrusters, which is why they are not yet used for primary propulsion. But in the future, when nuclear reactors will be available for space use, these thrusters could become a reality. And could also be used for human missions to Mars or beyond in the solar system. In conclusion, electric thrusters can be the future of space exploration. With their efficiency, high specific impulse, and ability to be turned on and off as needed, they are perfect for deep space missions. And as technology continues to improve, MPD thrusters in particular have the potential to become the primary propulsion system for future space missions. So, don't miss the opportunity to stay updated on the latest advancements in electric propulsion. Make sure to follow our channel and turn on notifications to never miss a beat. And if you found this video informative, please give it a like and share it with your friends, to spread the word about the exciting potential of electric propulsion. Thank you for watching.